Okay, so welcome to seminar. Okay, and good morning, everyone. So, okay, I know Sunday you have to force you to come, but trust me, it's gonna be useful for you lah. Okay, because you will face more exam questions. Okay, so later on you can use it for exam lah later on. Okay, so but chapter one I'm not gonna talk much. Okay, because in normal notes. In March normal notes, I include it. So you can just read through because chapter one will not come out a lot. Maybe like come out objective like one or two questions. Okay. So they mainly, even though they come out, don't worry. Okay. So loose mark is okay. Because later on, like you see like in Form 4 year-end exam, Form 5 exam, you won't see the chapter one anymore. Okay. So normally our important one is Form 4 chapter 2, Form 4 chapter 3, and Form 1 chapter 4. Since many of you tell me that you come out until chapter 4. Yeah, so in normal class, I taught until group 1, right? So that's why mainly today I just cover chapter 2, chapter 3. Chapter 4, I cover a little bit of group 18 and group 1. Okay. So before that, okay, I just do a summary, simple summary, okay, before I do questions. Okay. So for chapter 2, okay, because the notes I don't want to teach too much because later on, not enough time to do questions. Okay, I just do a summary. What do you have to know? But if you have any question, you can ask me. So the first part is, as you know, okay, the state of matters, okay, solid, liquid, gas. So solid, liquid, gas. Then you can, solid, liquid, gas. Then you can uh, study the experimental setup, okay, and the graph you have to know. So as you know that the exam question they ask, why the temperature doesn't increase? Why the temperature is constant? These are the things you have to answer in an exam. Why the temperature constant? It's already a fixed answer actually, right? But I don't want you to just memorize the answer. Okay, so you must have with a little bit of understanding before you answer the questions. So in this case, temperature constant because the heat energy absorbed by the particles used to overcome. Now you might not answer what I'm saying, okay, at all. So very simple one. So because the temperature increases during these phases because why? Because they used to increase the temperature. The heat energy used to increase temperature, but here they have to change the state. They have to overcome the particles. You know what's overcome, right? Do you know what's overcome? Overcome means you split, you distance the particles. Notice at solid, right? The particles are not distanced. The particles are closely packed together. But when they become like this, they are closely packed. I mean, not closely packed, but they have more freedom, more distance. You split the particles into further part. It's called overcome the attraction force. So that solid can become liquid. So this is the fixed answer. Okay, when they ask based on the graph, why temperature is constant? So, and other precaution you can try to reach. Okay, mainly why you have to use water, why do you have to stir? All because you want to get the even temperature, even heating. Already like there are shortcut to memorize one. Okay. So but just now for heating, right? Cool down also got another explanation. But don't worry, later on we do exercise about it. Okay. And I think this part is not popular. You can look at page 2, right? Have you got the seminar, right? Seminar notes. Even if you don't have the seminar notes, physically, you can refer the PDF file because I already sent the group, right? In case you don't know where to find. Okay. And then, atomic structure now. This one, I will do question also later. What is the meaning of nucleon number, proton number? For sure, will come out one of them. for sure lah. They'll ask you what is the meaning, what's the definition of nuclear number or proton number. Remember, nucleon is the total number of proton and neutron in the nucleus of an atom. You must say in the nucleus. I told you, right? Inside nucleus contain proton and neutron. And outside one is electron. Isn't it? So, and also they ask the meaning of proton number. So can just read through, okay? What is the meaning of isotope? These three lah. Meaning they'll ask these three. Okay. So later you just do exercise right now. Okay. And question also they ask you to draw electron arrangement and atomic structure. Okay. So this one be careful. Don't make a mistake. Okay, because exam always doesn't matter if first exam or second exam or third exam or form 5 exam. Student always forget this. Because chapter 2 is the first lesson we learn, right? Other than chapter 1. So that's why you might forget. So the drawing is the same. If the proton number is 13, the electron arrangement is 2, 8, 3. Because you learn, right? First shell maximum only occupy 2 electrons. Second, third shell maximum can occupy 8 electrons. So that's why in this case, okay, that's why in this case, you can see that you got 2, 8, 3. Okay, but same thing for atomic structure. It's just that you change the symbol of your element to how many proton, how many neutron. That's all. In case you ask me where to find neutron, where? Okay, so exam, let's say they give you like this. You know that? How do we find neutron? Because based on this formula, nuclear number equals to proton plus neutron. So you just minus off. 27 minus 13 equals 14. Example lah. Okay. So notes I just agak go through, then I do more exercise. Because there are some exercises that I couldn't do in normal class. Okay. So isotope, remember isotope means inside have the same number of protons, but different number of neutrons. So they are the same element, like carbon, carbon, carbon. They are all carbons. It's just that, notice the nucleon number different, which also cause neutron to be different. 12 minus 6 is 6. 30 minus 6 is 7 neutron. 40 minus 6 is 8 neutron. So that's why here are the similarity and differences. And these calculations shouldn't get wrong. Shouldn't get wrong. Later I'll do with you this calculation. Very, very simple one. Okay. So just to find the average mass of silicon. So very simple. You just use nucleon number multiply percentage. For everything, multiply percentage. Then you add together. Divide 100. That's it. But don't worry, you do the question. Okay, and the uses of isotope. Just memorize this. Especially like cobalt 60, iodine 131, carbon 14, sodium 24, and phosphorus 32. These 5 I would say important. These 5 I would say important. Okay. For sure, not to say for sure, but possible come out exam. Okay, uses of isotope. Okay? But don't worry, again, at the beginning, I just do summary. So the real is when you face the questions. Okay? And this chapter 2, this is what you have to know for chapter 2. The heating curve, okay, the graph, the state of matters, the process, like how the solid become liquid, okay, melting, boiling, condensation, sublimation, freezing, all this stuff, okay. Then the atomic structure, how do you draw the electron arrangement and or atomic structure, meaning, all have no, okay. And then how to calculate the relative atomic mass of an element for isotope, uses of isotope. I tell you which one to study, okay? It seems a lot, I know, okay? That's why science stream is like that, okay? So if you want to take it serious, please study lah. Don't and one more thing, based on my experience, don't just read through. Don't just think I close my eye then I can get A lah. No. So what you do is you can read through the notes, of course. Not to say read through lah. I would say the best is when you do exercise, when you don't know the questions, then you only read through you go through the notes. Don't just copy, read through. Moving pen also important lah. Okay. And then page 3. Okay. Now this one, I told you during this normal class, I told you that formula always have to remember. So won't give it an exam. Okay, this one you have to memorize. So all this simple, cannot get wrong already. Okay, so you have to start now. You have to start. I told you right. You have to start like even for the past few months, maybe you still don't know one formula. Don't worry. From today, one by one, you start to memorize. So because later on you'll be troublesome if you don't know the formula. Okay, acid formula, gas formula. Notice the gas cannot write just N. When you ask you to write equation you have to write N2. Sometimes you see oxygen is O2 at the bottom. Okay, important to take note. So so this one, because this one like no point. I just like now I ask you to memorize formula one by one like this. Blah blah blah. Okay, no point. So I can just go through it. Okay. It depends on your effort when I'm not around. Okay. So because we have done this in normal class. So and also I'm sure in school also you learn already. But I use this time better to do exercise. Okay. Especially these ions. For sure, not everything coming out. Of course, you must ask me, oh, exam come out like this. Come out, all the ion here. No lah. Okay. So exam maybe they randomly ask you, write the formula of, let's say, potassium hydroxide. Potassium hydroxide, you don't know. Potassium is K plus, hydroxide is OH minus. This why when they combine, you will get KOH. Do you understand me? So let's say they ask you to write calcium chloride punya formula. So calcium chloride. So how do you write? Remind again. Okay. So in case you still don't know what is happening. So always to cross. You see the number of charge and you cross. Just in case forget already. You see the number of charge and you cross. So the 2 we give to Cl. The 1 we give to Ca. But I won't talk through everything. Okay. Any question you can PM me. So you can WhatsApp me. Okay. I'm sure you have my number, right? So these are ion. But not every ion memorize. This one no need to memorize. This part no need to memorize. In our syllabus no need. Okay. So you memorize the important one like this. All these simple one you memorize. This part. Okay. And then chapter 3, this formula. Another one. Okay, that's why chemistry, two things. Two things that confirm come one. Okay. You have to use as a basic. Number 1 is formula. To create a formula and the charge. Okay. 1 plus or 2 plus or 3 plus. You have to certainly you have to make it clear. Okay, in your mind. And then this one. Okay, this one, number of mole. Exam, again, remind you, not coming up formula. These 3, memorize. Memorize, okay? So, will come up. Mass over molar mass. Doesn't matter which exam, I can just tell you that this one always come out. Doesn't matter in objective or structure or essay. This one always come out. Volume over molar volume. Number of particles over Avogadro constant. I do some question later for this also. Okay, just to remind you a bit. Okay. And then the MGO experiment. Okay, I'm sure you done in school, even in physics class, I show you already. Okay. So what happens is they might ask you, I don't know. Okay. Later I ask you to write down also. and then they might ask you some application. They might ask you. They might ask you some application. Okay. Can I? Any question? Application of what? Like before you put magnesium into the crucible, or why do you have to use sandpaper to scrub? This kind of thing they ask. Important here actually. You can read through also. Then you do exercise. Okay. So why do you have to use the lid to close the crucible? Why you cannot just leave it open? They ask this kind of question. Okay, very normal. So remember, do not let the white film of MgO escaping. 1 mark already. Okay. So why do you have to use the tongue to lift the lid slightly from time to time? Why so? You have to answer the question. Okay. Because you have to let the, because this reaction is Mg plus O2. If you remember, magnesium plus oxygen, you will get magnesium oxide. So that's why you have to let the oxygen gas to enter to react with magnesium. See. Okay. So I'm sure you've done this experiment, right? And then the other part, I'll just talk about it later. Okay. The CUO experiment, same thing. I'll talk about it later. Okay. So same thing about the precaution, everything. Then the group one elements, I only taught you just not long ago. Okay. So yes. I would say the hardest side, I say my chapter 4. So because chapter 4 got a lot of equations, got a lot of observations, okay, got a lot of things to memorize. So I would say chapter 4 hardest. Chapter 2 will be easiest. Chapter 3, I would say medium. Chapter 4 hardest for your case. Okay. But don't worry. Okay, I think I should do exercise. Okay, no point I'm talking about it. Chapter 1 also. Okay, chapter 1 you can memorize few things here. Okay. Okay, so if no question, I still do a question. Okay. Page 11. Do you have a notes page 11? Okay. So now diagram 1 shows the standard representation. Now exam even they ask you write down the standard representation. Possible, huh? So what do you have to do is on top you write the nuclear number, on bottom you write proton number. Then you write the symbol of element. Let's say if I ask you for, let's say for sodium, then you write Na here. Let's say if they ask you to write carbon, then you write C here. And they ask, now this one, what is the meaning of proton number and nuclear number? Write down first. Who can answer me? What is the meaning? Proton number, actually just can copy, just double the meaning. Proton number is number of proton in the nucleus of an atom. You have to write in the nucleus of the whole atom. Meaning, okay, you must be meaning, do I have to write full? Yes. Chemistry, yes. You have to write the exact one. Your teacher will just follow the answer scheme and just mark. They want to see the whole thing. They only, you can get 1 mark. Nuclear number. Nếu mà thôi nuclear number is proton added with neutron. But you cannot just like added with neutron. You have to say total number of proton and neutron. Write down first. Write down first. Same thing, in the nucleus. Today we will look at question. Okay. And hope your morning brain will be helpful for you to absorb these things. Yes. Okay. Done. Okay. So first part settled. Can. If you see like you feel like, oh, I cannot write down by my own, then you write down on your own for your own exercise later. Blah 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 give you for sure Serena cannot finish the question, right? So write down your own. Okay. Number of electron. Now, all these are atoms. They tell you, right? Do you know what's meant by atom? Atom means no charge. Like example, sodium is not sodium plus. Okay, all these are atoms. Atom is the number of proton equals to number of electron. So it's like for atom T, if you got 19 protons, then you got 19 electrons. Very simple. Okay, actually T is potassium, right? So if K, you got 19 proton, then you got 19 electrons. But if K already donate 1 electron, then I show you the experiment. Okay, potassium donate electron become potassium ion. So now it still got 90 proton, but the electron has been donated out. So it become 18. Yes, it become 18. So if they ask for ion, then the number is different. What is the number of neutron? Now, neutron, the formula, they tell you in this sentence. Nucleon number is proton plus neutron. What if I want to find neutron? What should I do in mathematics? The proton move to the other side, become minus proton. Nucleon number minus proton number. So for T, 39 minus 19, you get 20. These are the small things that you ask. Don't answer you ask, don't keep quiet. I know it's early morning, don't just sit through. Define isotopes. Okay, so isotope means have the, okay, 3 things I have to write. I show you better. So same element, atoms of the same element. Okay, like just now I show you. Doesn't matter, carbon, 12, 13, 14, example. All are carbons. Then the proton number is the same. But nucleon number different. Okay. It means you must have different nucleon number, but same proton number. Yes. 10. Important. I think lah, the meaning will ask either this or this one. You must me why you got slash one. Now, exam, right? They will either accept this, pair with this, or same number of proton, different number of neutron. You choose either one to applicate, to apply. Okay, don't write this mixed with this. No, just follow the pair. If you write number of proton, then you write different number of neutrons. Which pair of atoms are isotopes? Okay, so based on this meaning, who can tell me which one is isotope? RSTU. Which one? S and U, yes. You can see properly. Same number of proton. Bottom is proton, on top is nucleon. Yes, very good. Okay, very good. So S and U, but again, I remind you, okay, explanation, you always have to say atoms S and U. You have to have the word atom. Yes. So the teacher like to catch a small thing. You believe me? Okay. Yeah. Even in chapter 4, I told you, right? When you explain, you must have the word atom. Is that clear? Okay. Same atom as you, same proton number, different nuclear number. Just say, just answer based on what you see. State two different physical properties between two isotopes. So, physical properties, if you see the word physical properties, normally these few things are possible. Melting point, boiling point, atomic mass, or solubility in water, or electrical conductivity. But you learn just, in this case, you can just say about melting point, boiling point. Okay, so you can say they have boiling point, melting point, all this stuff. Density, atomic mass. Yes, it must be isotope. Isotope have different physical properties, but same chemical properties. Physical properties is like based on their own characteristics. Chemical property means chemical reaction, like carbon, the 12, 13, 14. So all these actually can react with oxygen gas. Doesn't matter which one. Doesn't matter is 12, 13 or 14. All can burn with oxygen to get carbon dioxide. You will get the same result. This is called same chemical properties. Will the two isotopes react the same way when heated with oxygen gas? So, yes, this is the chemical properties. React the same way. React the same way means talking about chemical properties. Then you can say, yes, they have the same number of valence electrons. Yes, you ask me, how do you explain this? Okay, so carbon 12, carbon 13, carbon 14, right? All these have same number of proton. But the most important thing, you have to explain based on valence electron. Now, you have to get the electron arrangement, which is 2.4, right? For all 2.4. And they got how many valence electron? 4. I told you, right? Valence electron means the electrons in the valence shell, the outermost shell, the most outside shell. Remember? Okay. Okay. Isotopes are used in the medical, industrial, ecological, and agricultural fields. This one they will ask you also. Okay. So use of isotope. Okay. The most common is cobalt 60. Okay. To kill cancer cell. In medical term, agricultural, you can put phosphorus 32 uh, as a phosphate fertilizer. Okay, by plants. Okay, all these connect first. Archaeological, carbon 14. Okay, to estimate the age of fossils, like wood, like fossils, all this stuff. Like you can example, like you can estimate, oh, how long has the dinosaur dead? already. So you can study that. Okay, using carbon 14. Sodium 24 to detect the leakage in underground pipes. Means you might ask me what does it mean? Means you can know which is the exact location that the leak pipe that the pipe leaks. Yeah, so you don't have to correct all the soil to find out where is the pipe leaking. You can use this to detect. So can I? This one is more of the proton isotope. Okay? No question already. No question are so good. Ayo. Okay. Suggest the physical state of substance. Now this one, you must ask me, hey, when you see this kind of table, how do you know? How do you analyze? Very simple one. Okay. So first of all, you have to see the keyword melting point, boiling point. What is melting? What does melting mean? Change from what state to what state? Solid to liquid. What does boiling mean? Liquid state to gas state. So you do this kind of analysis first. And then what you should do? And then they ask, what is PQR at room temperature? How do we solve it? How do we solve this? Okay, what is the chemistry room temperature? 25 degrees Celsius. 25 degrees Celsius. So you just see lah, which one can fit in 25? Very simple. Which one can fit in 25 more? Properly. So P, you see negative 89 already become gas already. So it means 25 is after negative 89. Q means in the middle, right? 25 is between 15 and 70. So you just put in the middle. R, 25 is smaller than 900 and 2003, 2030. So that's why you put here. That then you know P is gas, Q is liquid, R is solid. Simple. Huh? Okay, so there's this one calculation for sure you come on. Okay, I would say like 80% chance. So they tell you you got two isotopes, boron 10, boron 11. Boron 10 in the earth contain 19.9%. Boron 11 contain 80.1%. What is the relative atomic mass of boron? So basically what you should do? You take the mass, okay? Nuclear number actually is also known as the atomic mass. So 10 times 90.9 plus 11 times 80.1 divide by 100. Finish. That's it. It's so simple, isn't it? To get 2 marks. Just percentage multiply mass. Finish. What is the answer? Hope you calculate this out. Okay. Okay, very good. 10.8. Can keep as three significant figures, okay? No problem. Okay. Now, the other one, a bit tricky question. The other one tricky because sulfur 32, sulfur 34. So data shows that the whole mass, now, the balik question, instead of giving you the percentage, they didn't give you percentage, they give you the mass that already calculated, but they ask you to find the percentage. So this one is the balik question. So then you have to assume this one how many percent, this one how many percent. Sulfur they do, sulfur they do how many percent. So let's say I assume sulfur they do is like Y%. Then what is the sulfur they do percentage? What is the percentage? What is the total percentage available? Total percentage. 100%. So you use, if here got Y%, here 100 minus Y. Very good. Okay. So let's say this one is 60. This one you have to use 100 minus 60 to get 40. Example. But since here you don't know anything, right? So you just use Y. So, but do the same thing. Y% multiply 32 plus 100 minus Y multiply 34 divide 100 equals to the 2.1. So what do you get? After mathematics, what do you get? Okay, you open bracket, right? 32Y, open bracket, uh, 3,400 minus 34Y, right? Mathematics, you get around 95, right? Correct. This one is a mathematics skill issue. Okay, if you couldn't get this, yeah. So basically, this one move, these two move to the other side. Finish. And then it means sulfur 32 is 95%. Sulfur 34 is 5%. Because they ask for both, right? Abundance for both isotopes. Okay? This one is more tricky question if they come up. Done? Okay. This one, now this page, go and do yourself. So I give you a task. Okay. So because I have to do this, I don't want to do the same thing right again. No one. Okay. And then you look at page 13. Page 13. This one is the naphthalene experiment. I'm sure most probably is your first school experiment. Okay. So you use Bunsen burner to heat the naphthalene until it melts. Okay. So very simple. But you have to use water to warm up the naphthalene. You cannot just use fire to heat the naphthalene. They ask why? Why you to use water bath? So what happens if you use if you just hit like this? What happen? What do you think? Catch fire? Not just catch fire, but explode. Another thing is the bottom one is too hot. Maybe the top one is a bit not hot, cold. So that's why the temperature is not even. Okay. If you use water, then water can make the whole naphthalene in the same temperature. You say distribute heat evenly. So not encourage this one. Okay. Why do we have to stir? The answer will be around the same. You have to make sure to get uniform temperature. Stir same thing to make sure inside all parts of naphthalene have the same temperature. We call it uniform. Same thing. So does matter question how they ask? The answer is quite clear, quite near one to each other. So you say uniform heat, even heat. This one you say uniform temperature. Explain why. This one. I think they come out this question. Okay. Why temperature remain constant during melting? Means you see a graph something like this where there are some movement, the graph, the curve doesn't increase. Why so? What do you have to say? When you heat, what happen? Let's say during melting. This one during melting, what happen? When you heat the particles, what happen? What does the particle have to do? Have to absorb the heat energy to, this one is called to overcome the force so that solid can turn to liquid. So heat energy absorbed by particles to overcome the forces of attraction so that solid turn to liquid. Okay. And then sulfur has the melting point of 114. Can melting point of sulfur determine using water bath? Cannot, right? Okay, because when you heat the water, water maximum only can reach 100. Then already boiled or I can call it evaporated. Okay, so cannot be over 100. If it is over 100, you can use water. You can use water, you have to use like oil or something. Okay, boiling point of water is 100, lower than the melting point of sulfur. That's it. Then you replace with oil bath. Oil will be much better. Leggy, you're leggy. No, no. I feel some people just let out. Okay, let out, never come back. Yeah. Sketch. Okay, this one. Okay. So sketch the heating curve. 2 marks. Okay, you must have label also. So label the melting point of the lead 80. So y-axis. First of all, you draw y-axis. Label temperature. Unit degree Celsius. X-axis time. You can put second, you can put minute, anything lah. And then draw the curve. Get the curve. Increase, constant increase, simple. But you have to draw a bit of curving. I think this one is good enough. Label melting point 80. That's it. Can. Done. Drawing done. Okay. This one, the bottom one, you do yourself already. So like no point in repeating again the same thing. Okay. So I'm sure you know how to do already. You can just refer the front page. Do the same step. Okay. And then this one, page 40. Okay, melting point and boiling point of methane is negative. Melting is negative 182. And then boiling point is negative 162. Label temperature X and Y. So which one comes first? Melting or boiling? The graph going upwards, right? So it's supposed to be melting first, then boiling first. So melting is supposed to be Y, right? Y is negative 182. This one negative 162. So P to Q, the physical state is solid. Q to R, mixture of solid and liquid. RS, liquid. ST is mixture of liquid and gas. Because liquid is on the way become gas. Then TU is gas. Exam, if you see this, you have to write mixture of liquid and gas. If they ask QR, mixture of solid and liquid. Meaning, Canada first, teacher must see, you must have constant temperature for meaning of melting point. Then you can say solid changes to liquid. At fixed pressure, you can say fixed pressure, specific pressure, or certain pressure. Either one can. Answer scheme accept this three. But you must write now. You must have this at the back. Three words. Constant temperature, solid change to liquid, say, at certain pressure, a specific pressure. Freezing point, freezing is liquid to solid terbalik. But you still have, right? Constant temperature, liquid to solid at fixed pressure. Okay, so that's why meaning they will ask either meaning of melting point, boiling point, freezing point. Then they will ask by proton number, nuclear number, isotope in this chapter. Yes. Not that they will not ask everything, but they will ask like maybe one or two. They mix question one. So they won't you won't expect the whole thing come out like this. Ooh, no. So they will take like maybe like few parts cells. Okay, so we do the D2 one because D1 we already done, right? This one is this one. Okay, so why temperature remain during freezing? So just now we did a question about why temperature remain unchanged during heating. This one is freezing. Freezing, you say like this, okay, it's a bit of memorization. Okay, because even if I speak too much, you won't understand. Okay, so heat loss to the surrounding balanced by heat energy released as particle attract one another to form solid. Okay, meaning liquid will attract each other, right, to form solid. So when this I talk about, right, when solid turn to liquid, isn't it the solid will absorb the heat energy? If liquid change to solid, the liquid will release the heat energy to become ice. Water become ice. But in this case, it's equivalent when this particle release heat energy equivalent, okay, when heat loss from the container to the surrounding. You have to say the whole thing is balanced. But I'll say that this one require more exercise, more writing, so they can remember. Okay, okay. Diagram A and B shows the graph of cooling curves of naphthalene plotted by two different students. So you can see that this one normal pattern, okay, decrease, constant decrease. This one, like this, you got a different shape, okay. So where even when the liquid particle hasn't completely changed to solid, but already lower than the freezing point. T2 is freezing point. Obviously, liquid becomes solid. So you might ask me why it's like this, Okay. If they ask what is the difference, A drops uniformly. Uniform is like normal, okay, drop evenly. heat distributes evenly. B, drop drastically. Drastically means like drop very fast. Like when aeroplane got accident, like this. Okay. Normal aeroplane is like this one. Okay, very uniform one. So but if the aeroplane suddenly lost control, they become like this. When you see the movie, so like going downwards or something. Suddenly drop very fast. Okay. This is called drastically. Drop until over the freezing point. But even not yet become solid. So which is like not supposed to be. Okay. They might ask how come like this? How come? I don't understand. Okay. So that's why exam you must have precautions. Okay, for cooling. You must use conical flask. If you just take out a conical flask, outside wind, when you cool down, right, the outside wind you just blow. Cold wind, you just blow. Blow, it becomes suddenly. That's why you cause the temperature drop very fast. Okay. So that's why it's called super cooling for art. How to overcome? Overcome, you have to stir continuously. Since I think they already use conical flask, right? So that's why the only wrong thing maybe he did is didn't stir properly. Okay? So quiet one, I think. Hope you're okay. Okay. And then and then okay, this one I don't do because this one is like you did in a secondary school. Okay. I mean primary school, so I think you did. I think so. Form one, form two. Okay. Arrangement, movement, okay, and attraction force. Okay, I would say even exam early come out. But of course, possible come out, but not so lah. Okay, the chance is a bit higher lah. I mean a bit lower. Okay, so you can just I would say you can just screenshot. Okay, I won't explain much. Okay, so what is page 15 lah. You just screenshot. Later you can go back, right? Because this one nothing much to explain about. Okay. Just the normal stuff. Okay, the movement, solid, of course, cannot move in fixed position. All this you can write down. So gas have free, constantly moving, high speed. Okay, all this. Attraction force, of course, solid. They are closely packed to each other. That's why they are very strong. But exam they will ask. They will ask like maybe one or two mark. They will ask like, uh, what is the attraction force for solid or for gas? So you can say one is strong, one is weak. The gas is weak. Okay, or they ask kinetic energy, you say solid is low because it cannot move. Cannot move means no energy lah. So gas have the high energy. So remember, attraction force, say strong or weak. Just not forget. Okay. But others I would say not much lah. Okay, around the same thing. And then I will do chapter 3. Okay. Page 16. Because left one more hour. Meaning, chapter 3 also got two meanings. Meaning of empirical formula, molecular formula. Okay, so empirical formula, you can say that. Chemical formula shows the simplest ratio of atoms of each element in a compound. Teacher, do I have to write whole thing? Yes. Yes. Okay, you know what simplest ratio mean? Eh? Maybe I should explain to you one more time. Like the formula of glucose, C6H12O6. Now, this one is not simplest. This one is molecular formula, the real formula. But after simplified, because the ratio of this is 6 to 12 to 6, so all of them can divide by 6. So now, if you divide by 6, you will get CH2O. And then only this one is empirical formula. Now the ratio is 1 to 2 to 1. Simplest ratio of atoms. Just a reminder, means the simplest, like a fraction, 6 over 12. Then you simplify, become 1 over 2. This is the simplified version. This experiment, CuO, most of you didn't do in school, okay, but don't worry, we have discussed already. This one is what experiment? This one is the copper one, copper 2 oxide react with, when these two add together become hydrogen gas, okay? Then the hydrogen gas will come up from here to react with the black color copper 2 oxide. Yes, copper 2 oxide is black. Yes, don't be curious, okay? So, how do you dry hydrogen gas? Okay, you can flow through anhydrous calcium chloride with the S. Because you can see that hydrochloric acid, the flame mixed with water. Okay, mixed with water and zinc. So then only because actually I told you earlier, acid needs water to show its acidic properties. That's why you cannot just say I take acid powder cannot. I must take acid solution. Okay, so that's why when the hydrogen come out from this, surely your hydrogen gas is wet, but you don't want your hydrogen get wet. Hydrogen gas is wet, so that's why you have to dry this hydrogen gas using anhydrous calcium chloride. Purpose of using zinc granule, okay, very simple. Okay, you can just say to produce what gas? Hydrogen gas. This is the experiment where CuO turn to Cu. Okay. You got two experiments, right? Chapter 3, you got two experiments. MgO and the CuO. This is CO one. Okay. Why don't why you must what is this? Why don't you use Bunsen burner? Why you use spirit lamp filled with ethanol? Spirit lamp, the fire is a bit smaller. If no, you see the tube so small, radius so small. What happens if you heat using Bunsen burner? Bunsen burner have a lot of heat energy. If you just heat like that, the whole thing will crack. Cannot tahan against like very high heat energy. That's why you use the small flame. And you might ask why inside put fuel ethanol. Ethanol is a clean fuel. It's a clean fuel. If let's say if you use Bunsen burner, you can see like when you burn, it become like black color. When you cook, suddenly your meat become black color. If not enough water, not enough whatever oxygen. But ethanol is a clean fuel. You won't have a black color below this tube. No, very clean. You won't blacken your tube. But can we get a question? Between this and this, sap and zinc, plus hydrochloric acid become Zn. Okay, wait. I show you the thing. Zn is 2 plus H plus Cl minus. So positive will attract negative. Positive will attract negative. So Zn2 plus will attract Cl minus. So what do you get? Zn1 Cl2. H means come out. What gas? Hydrogen gas. H2. Many people forgot. Okay. Balancing equation. How to balance? Right side got 2H. Left side only got 1H. So multiply 2. Settle. Observation means changes can be seen after the oxide of copper is heated. At the beginning, it's black color. Okay, Cu is black color. After you heat, you go back to Cu. This is brown color copper. So you can say black solid turns brown. Determine the empirical formula of oxide of copper. Okay, so you got, okay, find out, you got first experiment, I mean not first experiment, but before your tube, your combustion tube, before you put anything, empty is 135 gram. After you stuff the copper oxide, you get 151.1. After you heat, you become copper already, then the mass decreases to 147.95. So which one minus which one? Now in this case, okay, if you want to find the mass of copper, 2 minus 1. 2 minus 1, you will get copper. Remember, if exam they ask you to find empirical formula, you have to do this table. Okay, where the first one is element, then followed by mass, number of mole, ratio. Three minus two. 3 minus 2 is like that. For oxygen, it's 3 minus 2. To get the mass of oxygen, minus, 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 copper minus, you will get oxygen. This also will come out. And then after you get the mass happen, what is the formula for number of mole? Since you have mass, what is the formula? Number of mole equals to mass over molar mass. Molar mass for copper 64, O is 16. So just divide. Copper divided 64. O divided by 16. So both you get 0.2. Same thing. So then the ratio just divide by same thing, which you will get 0.1. I mean 1, sorry. Which you will get 1. By right, you should divide smaller number. But since both have the same number, you just divide same number. That's why empirical formula 1Cu, 1O. CuO. Hope your brain can have enough storage. Okay. All right. A balanced equation for oxide of copper and hydrogen gas. This one very simple. Oxide of copper means CuO. Oxide means got O. Got O, remember? Okay. So CuO like this. Hydrogen is H2. Now this one very simple one. I teach you one trick. This H rampas Cu punya girlfriend. Because you learn that reactivity of metal, you learn that hydrogen ion is more reactive than copper, stronger than copper. So now it will kick, okay, you will make sure it will kick the copper out and take the oxygen along to become together. So now H and O together become H2O. Copper becomes single. Okay, why does the hydrogen gas need to flow continuously before starting a heating process? Okay, it means this experiment, you have to let hydrogen gas, before you open the fire, you have to let hydrogen gas flow for 3 minutes. Why so? Why do we have this step? What happens if I just straight away open fire? What do you think happen? If your face close to this apparatus, your face will finish. Okay, your face will just gone. So very simple. If inside, for sure oxygen is everywhere. So that's why if oxygen is everywhere, then you just let the hydrogen gas react with oxygen gas and you open fire. Hydrogen react with hot air, explode. Dangerous. So that's why you must make sure you let hydrogen gas to flow all the oxygen out. Do you know why you got water here? Because you want the hydrogen forcing all the oxygen dissolve into this water. Yes. Okay. So that's why you have to remove all the air from gas tube. They won't ask everything for the precautions, but they'll ask like 1 or 2. But of course, I don't know which one they'll ask. Okay, so that's why you have to cover everything. Can the empirical formula of magnesium oxide determine using the same method? Okay, so this one for this CuO, right? Okay, I write down the reactivity. Kalau nak kawin mesti ada zinc fleksibel supaya perempuan hasil cukup anak. So you got potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, silver. So for the first 3, normally we don't do experiment because first 3 very reactive metal. You might get exploded. Let's say we just randomly hit potassium. Yeah, I already told you, even I put potassium into water, okay, for the normal lesson, I told you already, you just explode. I even show the video, okay? I burn my table, okay? So it's like in this case, potassium, sodium, dangerous. Don't just directly hit, openly directly hit, then the whole thing explode. No good, okay? So normally, that's why it's like magnesium. If you can see magnesium, right, the fire is only like, have a very, very bright flame. Okay, but normally for this part, we use this 5. We use iron 2 oxide, tin 2 oxide, lead 2 oxide, copper 2 oxide, silver oxide. All of them will become metal by heating with hydrogen gas. Yes, okay. But normally we use copper dioxide, normally. use copper oxide. Yeah. And then this is for the CO now. Okay. This is one part. Okay. Then the MgAlZn is another part. The magnesium, aluminum, zinc, this one, the crucible experiment. Then you can use either magnesium. Another replacement can be aluminum or zinc. This one, when you heat with oxygen gas, you become MgO, aluminum oxide, or ZnO. Normally. Okay, so here, if you answer, magnesium cannot. Okay. Now, why copper dioxide can, magnesium oxide cannot? Very simple, because hydrogen, okay, this is hydrogen. Hydrogen is here, between zinc and Fe. So, but hydrogen is more reactive than copper. That's why hydrogen rampas copper punya O, rampas away, right? But hydrogen is not is not, I say, is less reactive than magnesium. So that's why now the H2 cannot rampas the O, cannot. If you cannot rampas the O, right, can you have H2O? Can you have single Mg? No. It means, do you have changes? No. The hydrogen gas is allowed to flow until the product of heating is at room temperature. Explain. Okay, very simple. So even during experiment, you have to let the hydrogen gas to flow to make sure the oxygen gas cannot enter. Even after experiment, when you close the fire, let's say when you put down the fire already, why do you still have to let the hydrogen gas to flow? Very simple. So the reason, okay, because you must ask, I don't know fire already. I close fire already. After hitting means close fire, right? Then you won't explode. Now, in this case, after experiment, easily your CuO becomes Cu. The big problem is if the very hot Cu, right? If you straight away let oxygen to enter, what happens? The oxygen will react with the hot copper. If the oxygen react with hot copper, it will go back to CuO. Do you want it to go back to CuO? No lah. Okay. Susah payah, so difficult. Want to turn CuO to become Cu. How come I want this to go back again? Okay, no lah. So inside this case, you still cannot allow the oxygen gas to enter. Because oxygen will react with hot copper, go back to CuO. Which you don't want this to happen. Why do heating, cooling, weighing need to be repeated until constant is obtained? This one I told you before. Even for the magnesium experiment, okay? Even for magnesium experiment, you have to repeat several times until you get constant mass. Okay, example, like this CuO, let's say you will get, at the beginning, now let's say, beginning you will get 151.15. After copper, when you heat become copper already, become 147.95. Then you have to do the same thing again. You cool down, you weight the mass, you heat again, you cool again, then you weight again. If your value still the same, it means the experiment is over, is finished. All the CUO has already become covered. Yes. If your value suddenly, your value got like this, it means not over. It means you have to do again until you get the same thing. It means like this, it means not all the CEO completely become CEO yet. Okay. So you have to make sure or ensure all CEO completely turn to copper. If for the MG experiment, all the MG make sure to become MGO. So the question can be twist and turn. Right? Okay. Okay. Um, page 17. What is the meaning of molecular formula? So I can write down. Just now we wrote about the empirical one, right? Molecular means the chemical formula that shows the actual number of atoms of each element in a compound. Just like I told you, C6H12O6. This one the real formula of glucose, the actual number. For each one, for C6, for H12, the real one. You know what's atom, right? Okay, atom is like inside got 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. Element means like carbon element, hydrogen element, oxygen element of the whole thing called compound. Okay, this calculation. Okay, so they give you mass again. Do one more time. 1, 2, 3. Magnesium ribbon, magnesium oxide. This experiment, when you heat magnesium, you turn to magnesium oxide. Okay, you can see the white film coming out. After cool down, you get white solid. Okay, so if you want to find the mass of magnesium, 2 minus 1, you will get magnesium. If you get 3 minus 2, you will get the oxide. Do the same thing. Okay, after found your mass, you will get number of mole. Again, mass over molar mass. For Mg1 is 24, the molar mass. For O is 16. Normally they give an answer. You get both same, then you use 0.05 divided by 0.05. You will get 1. So that's why MgO is your empirical formula. Chemical equation, Mg react with what gas? What gas for you to enter? Oxygen gas. Just now is hydrogen gas. Okay. Mg plus O2, you will get MgO. Balance. Now this one you have to balance the equation because it's not balanced. Left side, right side element not balanced. O2, 1O. So multiply 2 at the right side. Now you got 2 mg at the right. So multiply 2 for 5 mg. Why was the crucible covered with a lid? This one. Why cover the lid? Because avoid white film of MgO escape. If you just left open, the white film coming out. Which the white film contain a mass. If you just let it go, open, never mind, let it go. Let it go then. The mass not accurate. That's why you can see a lot of students cannot get accurate answer. Very difficult. I would say it's a bit difficult to get accurate answer. So the white film coming out, then you see normal student, the mass not increasing on. The mass going down only. Going down only. Because you let some of it escape. Why is this method not suitable for the CO experiment? Okay, why you cannot use Cu become CO? Because bottom one, like copper, like silver, they are less reactive towards oxygen. And the reaction very slow. So that's why we only apply like the more reactive metals like magnesium, aluminum, zinc. Ensure how the reaction has completed. Complete means you might measure. Example just now, Mg 30.8 gram. After burning, I mean 39.7, sorry. 39.7 gram. After burning, you will get 40.5 gram. Then you do the step again. Heating, cooling, weighing, do again. If you get your constant mass, it's over already. Reaction completed. If no, still got increase, you have to repeat again. Precaution steps. Lid must be opened to let oxygen gas to enter. At the same time, you have to close, cover again with the lid to prevent escaping of white film. Okay. Then I think I jump to okay, this one. You look at page 18b. Yeah. Now, just now, right? This is the MG1. MG turn to MGO. This is CuO turn to Cu. So why you choose this metal? Mg, you react with oxygen, become MgO. CO react with hydrogen gas, becomes Cu. Okay, so metal X is magnesium. Okay, they ask why is metal X and Y. Magnesium, because magnesium is more reactive towards oxygen gas. Y is copper. Copper because copper is less reactive towards hydrogen gas. I mean not towards, but less reactive than hydrogen gas. So that hydrogen gas can run past the Cu punya O. Okay. This one they ask for similarities. Set 1 and set 2, the same thing. This one, same thing. Mg become MgO. The equation. This one is CuO become Cu. But do you know what's the difference? What's the similarity? They actually they ask compare and contrast. Means you have to have similarity and differences. Similarity is both using heating. Both using heating. Both involve heating and also both the reaction is between gas and solid. Means solid magnesium react with oxygen gas. So copper 2 oxide solid react with hydrogen gas. Same thing. These are the similarities. Differences, the table. Okay, so basically, let's say magnesium is 24 gram. And before that, okay, you got oxide form. This one you got metal form. You got metal oxide, metal. Also different. The product different. One react with oxygen gas, one react with hydrogen gas. So differences. This one exam, right? They will ask thousand way to ask you, but you have to, uh, understand what the answer scheme want. Okay. So react with oxygen gas, react with hydrogen gas. And then one more is, now just like home, right? Magnesium punya, the mass will increase one. Let's say 24 gram, you become 26 gram. But the copper dioxide, because magnesium gain oxygen, copper dioxide lose oxygen. So let's say got 147 gram. Now it become 145 gram. Example. So mass increase, mass decrease. Okay. Done. Okay. And then move on. Are you done? This one? Give you like 50 seconds more. Okay. So this one I do yourself. Look at page 21. It's 21. Okay. So now I said also you come up with this type of question. Okay. So they ask you to find the mass of 1 mole of vitamin A. So in this case, first of all, you have to find the formula first. How do we get the formula? This is the structural formula. How do you write down the molecular formula? So what I can do is you count lah. Each element got how many atoms? You count carbon, you could count hydrogen, you count oxygen. How many? Okay. So carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 carbon like this. Also possible, example. And hydrogen 1, 2, 3, 4, 5, 6, 9, 12, 15, 16, 17, 20, 21, 22, 23, 26, 27, 28, 29, 30. Okay. Oxygen, I think only got one, right? Only one oxygen. So the formula is C20H30O for vitamin A. So the monomer mass means, isn't I think they give right? So the RAM they give a relative atomic mass for hydrogen is 1, carbon is 12, oxygen is 16. So in this case, molar mass of C20H30O, just use 20 times 12 plus 30 times 1 plus 16. Because only got one O, right? 16. What do you get? 286 up. Molar mass, molar mass, you must have unit gram per mole. Gram mole negative 1. But they only have 5 for mass, right? Because what is 1 mole mean? Now 1 mole, if this one is 1, if molar mass got 286, what is the mass? 286 times 1 mole, 286 gram. This one is like this. 1 mole multiply 286 gram per mole. In mathematics, you know, right? So mole power 1 times mole power -1 means mole 1 plus -1. You get mole power 0. Mole power 0 means 1. Okay, obviously. Anything power 0 is 1. So that's why no more mole -1. Understand what I mean? Determine the mass of 0.025 mole. This one. Then you have to use mass over molar mass. Substitute 0.025 into this mole. Molar mass 286. Okay? What do we get? I'm sure all gone idea. All gone idea. You will get 7.15 gram. Right? So you multiply. Remember, how do you count molar mass? Remember, how do you count molar mass? Exam will come number of molecule. So you have to use the formula. Number of mole equals to number of particle over Avogadro constant. Remember, 6.02 times 10 to the power 23. This value. Avogadro constant. Okay. So they give you gram. You must start with gram. 20.02 gram. Okay, you put inside. Molar mass 286. You get 0.07 mole. And then use this mole to find number of molecule, which your Na is 6.02 times 10 to the power 33 multiply 0.07. What do you get? 4.214 times 10 to the power 22 molecules. Determine the mass of this. Now, if you see this, if you see like 10 power 22, 10 power 23, you know already, they give you number of particle. Okay, so but that's why you start with number of particle. Use this number divided by 6.02 times 10 to the power 3. you get 0.125 more. Use this to multiply molar mass 286. Okay, you will get the 35.75 gram. Can I? This one is the calculation only. Okay, so number of mole equals to mass over molar mass, number of particle over Avogadro constant. All in chapter 3. Ah. None. Okay. If you're done, page 24. Now, exam, if they ask you to find empirical formula, this table will not be given. Just to remind you, like that. Okay, they will not give this table. So you have to draw yourself. Okay, you close your eyes for this and draw yourself. Okay. So the first thing, label element, carbon C, hydrogen H, the others O. The mass, remember, if you see percentage, same thing only. 69.8% means 69.8 gram. You assume 100 gram equals to 100%. Hydrogen, 11.6 gram. That is. If you put gram here already, no need to put here already. The others remaining, total percentage how many? 100. So you use 100 minus these two. Which we get 18.6. Then all of them use mass over molar mass. 69.8 divide 12. 11.6 divide 1. 18.6 divide 16. Okay, you can put like three significant figure. And then, remember, if you see different value means what you do? You divide the smallest number. Which one is the smallest number? 1.16. So all of them divide by 1.16. Divide smallest number to get the ratio. Remember this step, element, mass, number of mole ratio. You will get 5, 10, 1. Now, in this case, what you do? If you got decimal place, you have to make it to whole number. If lah, okay, let's say it's 5.5, then you have to multiply 2. If here multiply 2, everything multiply 2. But in this case, no need because we have all the whole number already. So straight away you can take the formula is C5H10O. Finish. So the molecular formula. Now, if you want to find molecular formula, you have to use empirical formula. Okay, and they give you the whole mass is 172. Important in exam to read the keyword. 172 is the whole mass. Okay. Wait, wait. Pen no between. Okay. Like this. So you don't know how many times is the real formula. It can be 2 times, 3 times or not. You know, and how much? You don't know whether it's C10H20O or it can be 1 time also can. It can be 2 times, it can multiply 3. It can be C15H30. Don't know, so you put N times. So the whole mass 172. This thing equals to 172. Then you just put inside 5 carbon. So 5 times 12. Normally carbon is 12, right? Rm 12 plus 10 times 1 plus 16. N times is 172. So 60 plus 10, 70. So you got 86 N, right? Equals to 172. So N divide, you will get N equals to. So it means 2 times. So it means C5H10O times 2. You will get C10H20O. Is your molecular formula. Okay. We skip the third one. Look at this one. Okay, so this one is a bit tricky. It's your element. So no need to times 2. Which one times 2? Yeah, the O. Good eye catching. Okay. I become blind already. Especially early morning. Normally I wake up, when I wake up, it's only 1 o'clock. So I'm not so used in the morning. Okay. Good eye catcher. No problem. I saw this something. Yeah. Okay. I'm a night person. So because like my working time is like 2 o'clock to 10 to 11 o'clock to 10:30 like that. So my schedule is like flip. Because after working sure we have me time, right? Like the me time it's going to be at night. Okay. So but anyway, you got Fe2O3 ratio 2 to 3. Okay. So okay, in this case, where are now element is Fe and O. So 2 to 3, the balik question, they ask you to find X gram. So you don't know X gram of iron react with 5.04 gram oxygen. So you find the number of mole for oxygen first. Divide by 16. Which will get 0.315, right? And then because this one is X over over 56, they give you equals to question mark. Okay. So like you don't know, right? So what you should do? If you don't have X, you don't have mole. But we can use this information to find. Remember, you can take 0.315, divide by 3, multiply 2. Multiply the part that you want. Always, for the question mark. So X over 56, the question mark is, you take 0.315, multiply 2, divide by 3. We will get 0.21, I think. Then x, you just multiply. 0.21 multiply 56, you will get 11.76 gram. This one is the Malay question. Okay, we quickly do this one. Page 28. Okay. Okay, this one is actually came out in SPM 2022, if I'm mistaken. Okay, this question. So what happens? They ask you to write the chemical equation. Okay, for decomposition of sodium azide. So sodium azide, they give you formula NaN3. So NaN3 decompose becomes sodium metal and nitrogen gas decompose into arrow. Okay, so it means arrow become Na plus N2. Remember, nitrogen gas is N2, hydrogen gas is H2. They won't tell you in exam. Okay, so they ask you that chemical equation with balancing. You see it's not balanced. The number of nitrogen is not balanced. So what you should do? N3, N2. So N3 multiply 2, N2 multiply 3. Then here you got 2 Na at the left. At the right also times 2. So it becomes like this. If the volume of normal airbag is 57.6 dm cube, okay, so the airbag obviously is nitrogen. Okay, airbag is nitrogen. That's why they won't tell you. Okay. They tell you here. You have to read properly the question. Nitrogen gas produced will fill up the airbags. So it means if you airbag is the nitrogen gas. Sorry, 57.6 dm cube right now, right below nitrogen. Calculate the mass of sodium azide. So this is sodium azide. Below, put mass equals to question mark. So divide, because you get volume have information first. Molar volume is 24, so you just divide 57.6 divided by 24, you will get 2.4 mole. Three steps, find number of mole, do ratio, find mass. 3 steps. Always, okay. After found this one, do ratio, ratio from equation 3 to 2. Okay. Either I write in the question, I write in the sentence, or I do like this. 3 mole of N2 ratio 2 mole of NaN3. If you got 2.4 mole of N2, your Na3 is, now again, 2.4 divided by 3 multiply 2, because you want to multiply the thing that you want. So 2.4 multiplied 2 divided by 3. You will get 1.6 mole of NaN3. Either you write in sentence, or you can write this one. Okay. I'm sure in your school you write dot, right? After getting 1.6 mole, then you can find the mass. N is 14, Na is 23. So 1.6 for mole, mass don't know, molar mass. Na is 23, N is 3 times 14. Add together, multiply 1.6. Okay. The reaction between liquid ethanol with oxygen gas produce carbon dioxide gas and water. Okay. The ethanol react with oxygen gas produce carbon dioxide gas and water. Okay. You have to write the equation. I show you one more time. So it's C2H6O plus oxygen gas is O2. Carbon dioxide gas is CO2. Water is H2O. Left side got 2 carbon, multiply 2. Okay. And then 6H2H multiply 3. Count the O. 2 times 2, 4. 4 plus 3, 7. 7 O. Alcohol already got 1 O. So it means you need another 6 more, right? So 2 how to become 6? 3 times 2. This one is just balancing. Volume of unreacted gas. Now, they give you what information? 2.76 gram of ethanol. 2.76 gram. 6.0 dmq of oxygen gas. Volume of unreacted gas. Okay, so if you see excess, right? In excess, you don't have to use this information. You don't use this information. You use the no excess one. This one, you don't start with 6.0. No. Okay. So the total you pump into the experiment is 6.0. But the total reaction is not using 6.0. Okay. So you start with 2.76 gram first. Okay, so 2.76 gram molar mass. 2 carbon is 2 times 12. 6 hydrogen is 6 times 1. Then 1 O is 16. Rule ratio again. Ratio is 1 mole to, we're going to find the oxygen, right? 3 mole. So 1 mole of C2H6O ratio to 3 mole of O2. That's why multiply 3. If you get 0.06, multiply 3, you will get 0.18. Okay. Then you use this to find volume. Molar volume 24. Even then you will get 4.32 dm cube. This is total extra one, content extra. They ask which one unreacted, right? This one reacted with ethanol. Which one is unreacted? Use total minus the reacted one. Then you will get unreacted, the extra one. Unreacted is the extra one. That's useless. Okay. Which we get 1.68 dm. This one exam, they come out pattern many. Okay. Not straightforward sometimes. Okay. 9C, page 29. Now this one I didn't teach you in normal class, so you have to pay attention. Okay, this one is like this. Okay, in exam they ask you for qualitative and quantitative information. Okay, qualitative means you state out the Qualitative means you say out which one are the reactants, which one are products. Okay. And one more thing, and you have to say which one is solid, which one is liquid, which one is gas, which one is aqueous solution. You have to say out. Okay. Then they tell you one. You have to say liquid ethanol. You have to say oxygen gas, carbon dioxide gas, liquid water. Okay. This is qualitative. Quantitative, how many mole? Based on equation, like 2 mole of propanol. Like this, it'll say out. React with 9 mole of oxygen to produce 6 mole of carbon dioxide and 8 mole of water. Yeah. Okay. You must be which one reactant? Reactant is before arrow one. Reactant is these two. Before arrows is reactant. After arrows product. After arrow product. So reactants, liquid propanol and oxygen gas. Products, carbon dioxide gas and water liquid. This is qualitative. Quantity means number of mole. 2 mole of propanol react with 9 mole of oxygen gas. Okay. You will get 6 mole of carbon dioxide gas and 8 mole of water. This is quantitative. How you write? It's not important. Yes, yes. You have to write liquid propanol. Yes. They will give you the physical state. So you have to follow. Yes, important. Oxygen gas, carbon dioxide gas. Yes. State out the physical states. Yes. Done? Okay. And then you do one more lah. Then you finish. Okay. No more. For the chapter 4, because the chapter 4 I couldn't do many questions that day. So today I know today you got absorb a lot of information. So hope you can apply. Okay. And then this one, page 30. I just taught this chapter, right? This part. Name the gas evolved when metals of group 1 react with water. Okay. So I write the equation first. Sodium and water. Sodium and water react. Remember the day I show you the litmus paper become blue color because you got alkali coming out, the hydroxide coming out. The hydroxide and the hydrogen gas. So for physical class student, I'm sure you have smell, okay, very heavy hydrogen gas, okay, until you breathless, okay. And balance, 2H, 3H, I told you, right? 2 hydrogen, 3 hydrogen. So you start already, multiply longest, multiply 2. Now you got 2 Na and 2O. Then left side times 2 for Na times 2 for H2O. Hydrogen gas is evolved. Compare the reactivity of lithium and sodium towards water. So obviously, you can see the fire. I show you the video. Sodium is more reactive. They ask between lithium and sodium, right? Sometimes they can ask between sodium and potassium. So they also can ask. Explain. Now, exam, important. They have to see the keyword sodium atom, lithium atom. Sodium atom has bigger atomic size. Now, this one already. Compare size. The size is like this. Lithium, sodium, potassium. We have to say sodium atom has bigger size. Remember, what is in the center? What is in the center? Nucleus and the valence electron become further away. Remember, bigger size, bigger distance. Forces of attraction become weaker towards the valence electron. That's why sodium atom easy to donate valence electron to achieve stable octet electron arrangement. This one important. I think you come out chapter 4, sorry. But today I just do road one. Normal class I do, uh, I continue with Route 17 next week. But exam again, if the teacher didn't see the word atom, wrong. Okay, so I told you, right? Bigger size, distance between valence electron and nucleus bigger. Attraction force weaker. Means the electron easier to be let go, easier to donate to somebody. So that like example, like Na easier from 281 become 2.8. So content like 1 mark, 4 mark. Sometimes it can be 3 mark. If this say only got 2 marks, right? Or 3 marks. So if only got 3 marks, right? The second sentence no need to write. The most important is the size, attraction force, easy to donate electron. If you only got 3 marks. Write the chemical equation between sodium and oxygen gas. Na plus O2, you will get Na2O. Na is 1 plus, O is 2 minus. So you got 2O10 multiply 2. 2 times 2, 4. 4 Na. The white powder that form, white powder dissolve into water. White powder dissolve in water. Write the chemical equation. So I take the Na2O. I take Na2O plus H2O become NaOH also. The alkaline solution. They will turn the blue red litmus paper become blue. multiply 2 because Na got 2 at the left. Okay. Observation for both cases. Lithium, we have the red color flame. This one you have the yellow color flame. If you come up potassium, then you have purple flame, lilac flame. But both will form colorless solution that will turn litmus paper become. No, this one, if you dissolve water, yes, you will turn litmus paper become blue. Precautions. Okay. Do not hold with your hand. Okay. It's oily and it may be reactive, and later you get burned with your hand. Maybe. Okay. Wear safety goggles and gloves. That's why you can see the explosion. It's better if you wear something to protect. How do we keep in paraffin oil? Can. If they come out this one, Na react with chlorine gas, same thing, Na plus Cl2, you get NaCl. Multiply 2, multiply 2. Can? Any question? Okay. The last part, okay. No, I'm going to write here, okay, because later you can write. Okay. This one just to show you, okay. Just to show you that later on you write yourself, okay. Because exam will come out one of them, okay. Either you come out the describe experiment for the naphthalene one. I'll send the answer later. Don't worry. I'll send the answer later. Okay. And then the naphthalene experiment, I think this one will come out. Maybe lah. For the first experiment, I think it will come out this one. First time, first time exam in essay question. They will ask you to write procedure, ask you to draw. Possible, possible. They ask you to draw this one. Okay. You want the screenshot now, or you can. I'll show you the answer later also can. Can find page 36. Naphthalene, cheating naphthalene experiment. And then this one, the MGO experiment. Okay, the MGO experiment. Okay, can also come up. Ask you to draw, possible. Okay, this one, page 37. You want to go back and write as can? Page 38. The reason one, just only I told you one. Okay, put the group 1 element into water. What is the reaction? This one, page 38. Group 1 react with water. Either one, I don't know which one come up, but either one. Okay, so you can read through the procedure, exam you can write down if they come up. Okay, which is possible they come up one of them. Okay, so if no question, I think we can leave today. So sorry for late. Okay, but thank you for coming, everyone. So yeah, see you again in normal class. Okay, goodbye.